Here I have prepared a project in Spain to demonstrate the new construction type. I chose a traditional house with monk and nun tiling on a concrete roof, as you see is very common in Valencia. And so we need to choose the brick type, monk and nun. And the roof construction is already pre-selected for the Spain system as concrete roofing. On concrete roofing, we can fasten in a one-layered system in portrait and in landscape mode. So let's search the constructions. As you can see, we find two possible solutions. Modules in portrait and landscape orientation, one layer of rails fastened on Stockscrews. In the component selection dialog, we can see that a dowel is chosen for the selected Stockscrew as fixing component. Let's put the construction with the module field on the roof and see what the calculation results are. Now you can see that the Stockscrews are spaced evenly in every row, but with different distances for each roof area, because Solar-Planit has calculated the optimal position for each fastener. Here we use the freedom to fasten on a continuous plane anywhere on the roof, as the concrete substructure is not forcing us to fasten on a fixed grid. So we can use the maximum span width of the rail between the Stockscrews to support the loads in the current location. So we use less materials. And in the bill of materials, we have calculated the number of dowels, which corresponds to the number of Stockscrews used in this construction. And here you can see that for the loads in the current location, we calculated the static properties of the system for each roof area. And one of the results is the bearing distance of, in this case, 1.3 meters, which corresponds to a 100% utilization of the combination of Stockscrew and dowel. So we are using the maximum span width possible to use less materials. As usual, you can export the planning data into PDF. And the module array dimensioning is now a default option because we added some new features here. Let's look at the new features in the documentation for Stockscrews on concrete. In the load static section, we now print the bearing load capacity needed for the dowels, so the installer can choose a strong enough dowel. You can see that we need a tensile bearing capacity of 1.71 kN and a corresponding pressure bearing capacity. And I have added new information to the module array dimensioning plan. It now displays a blue bounding box, marking the positions of the outer fasteners on the roof so you can find your reference measurement.